Welcome, everyone. Greetings. My name is Amber Smith, and on behalf of Evolving in Education, I would like to thank you very much for joining. So we have a guest speaker here today. She is our head neuroscientist, Dr. Lee Raz. Dr. Lee Raz, I'll turn it over to you.
Thank you, Amber. Thank you, everyone, so much for taking time to be here today. I love Evolving in Education's mission, and as Amber mentioned, I am trained as a neuroscientist, so I just love the brain. And speaking of the brain, I have a brain model for you today. I thought, even though we are on Zoom, I would do this sort of in an interactive style. And my whole goal here is to bring the science into life. I think it's so important to do that nowadays, so we can have and make more informed decisions. Okay, so I have this mini talk, I call it, will be divided into 3 parts, and I really hope that this serves you. The first part will just be walking through some of the brain anatomy that I think is relevant to evolving in education and in achieving the goals that we are seeking, which and the main one being helping children learn better and reform some of our education system. And then secondly, I will discuss how the brain works. How does learning occur in children, which is such a fascinating topic. So I will give you a quick overview of that. And finally, I will end with giving you some neuroscience tools, some things that could really help you make more informed decisions as we move forward. And I would love after that to open the floor for questions, brainstorming. I think it is such a group effort here, this initiative. So I would love to hear from you following this talk. So jumping right in, I'm holding a human brain model. And if this was my brain, it's a pretty big brain, which is great. But if this was my brain, it would be located in my head like this. I know it's a wonderful look, but this brain is the first thing you can see that I would like to point your attention to is this pink part here, and that is called the prefrontal cortex. Now, this makes us unique as human species because we evolved such a magnificent prefrontal cortex that allows us to carry these higher order executive functions. What I mean is we're the only ones, right, that can plan and strategize and perform math. So this section is very, very important. So I wanted to start with that and to tell you also that if this was a brain model and now a brain model of kids, which I don't even know if they met them, but if they did, the kids' prefrontal cortex will not show up as developed as this full-size adult brain. And this is because we know from studies that the cortex in kids develops much, much later. And in fact, this is a fascinating point that I love to mention right off the bat to keep in mind, is that children can develop all the way, they used to tell us, okay, most of development in the brain for children happens from 0 to 5. Well, we would be in trouble as a species if that was true, right? You would agree that. So what we see and know now is that the brain can be molded and shaped all the way to the age of mid-20s and beyond. So we have a little wiggle room, and keep that in mind as we proceed. Okay, so the second thing I want to point your attention to is this beautiful map of colors. And this is because we have so many structures in the brain. And as we know it, the brain is the most complex organ. Now, it is more advanced than any supercomputer you can imagine. And that's why we haven't, as humans, been able to replicate it, not yet. And so how it works is all these structures come together and are integrated into making these complicated functions happen. So whether it's children or adults, all the structures are going to work together and form connections, which I will discuss in a minute and give you some examples of that. But it's all integrated in this when we think about cognition and how the brain processes things. Now, if I was to take this brain and slice it down the middle, which I'm about to do now for you. Okay, there. So inside, it gets even more fun and complex. We have the primitive brain here. And so this is something we share with other species, so it's super fascinating. So we have the medulla oblongata, and this is our connection to the spinal cord right here. Inside, we have, they call it our reptilian brain, because once again, we go back to evolution and how the human brain came to evolve. And so the brain evolves, they like to say, from the bottom up. What does this mean? It means that the primitive structures formed first. So we have this spaghetti-like structure that you could see here in green. This is called the cerebellum, which controls, it's well known to control our balance and motor functions, movements. Very important in the animal kingdom, of course. And then if you take a look down the center, this is our hippocampus. And this is so, so important because the hippocampus is the center for our learning and memory. And at the end of the hippocampus, there's going to be a little, almost it looks like a little dot, and that dot is the amygdala. So this is the center for our emotions and feelings. Now, so this is very fascinating to think that the brain is developing from this way. And then we end with the pink portion that I mentioned, the prefrontal cortex. And so, as I mentioned, in kids develops much later. So this is brain anatomy in a nutshell. Okay. So moving on to the second part, how does the brain learn? So I want to give you kind of a quick overview of what learning in the brain looks like. And so we think about a child. So first of all, a baby. Let's start with the baby. The baby is born with twice as many neurons as it will ever have as an adult. And what happens throughout this baby's life, we go through, the baby goes through experiences, let's say with loving caregivers. Then the kid later, as the baby grows, it has enrichment courses, right? Classes, from tennis to art classes. All of these experiences are going to shape this baby's brain. So what happens to, and now we're getting a little deeper, diving a little deeper into the neuroanatomy and the neural architecture of the brain. What we know is that the brain is composed of something we call neurons, and I'm holding two neurons. You can imagine two balls will be the neurons, and the brain has millions of these, okay, because these are the functional units of the brain, and these neurons are going to be connected by a highway of information, or a highway, we call these synapses. You can imagine just long strings of carrying information from one cell, one neuron, to the other. So what happens to this child, and I love to use this as an example, music. Let's take music. So as this child grows, and I did say it has twice as many neurons, well, as it grows, let's say at the age of 4, the child decides to take piano lessons. As you know, music is super beneficial for the brain, and music is also very complex in terms of what brain structures are getting activated. And so this child takes piano lessons, and what happens during the lessons, in terms of the neuroarchitecture, is the child will strengthen these connections between the neurons, right? The neurons that are going to fire, meaning be activated as the child learns a skill like playing music. So it's very complex, but what happens is when you think of learning a skill like playing the piano, you have the auditory cortex, which would be the ears. The child will listen to the music first. Then you have the visual input from the eyes. Let's say the child is looking at the teacher playing the notes, or maybe even later reading the notes. You also have the fingers playing. So this is fine motor skill. And finally, the prefrontal cortex that I mentioned, this is your thinking center, right? The executive function, which has to integrate and plan the right hand, the left hand on the piano. And so all of that, as I mentioned, integration in the brain is going to strengthen these pathways for music. And so what happens is this 4-year-old who begins as a new student in piano, fast forward 5-10 years, he becomes a piano master, right? These connections have been strengthened. but what happens to the connections in the brain, the potential connections that could have this child master the violin? Well, the child never practiced the violin, so those connections are dissolved by the body. So what it means is that we have a fun saying in neuroscience: use it or lose it. If the child uses those pathways, they will strengthen. If he doesn't, they're going to be lost. And that's how our environment shapes the brain. So this is super critical when you're thinking of teaching a child a new skill, you're thinking about a curriculum at school. So this comes into play in how the child brain learns. But guess what? This is also applicable to us, adults. This is how we learn. Now, children are much more efficient at this, but you get the picture. Okay, so that was in a nutshell how the brain works. And I also wanted to mention something very interesting as you think about this brain. I like to call it, I like to say that the brain is a mosaic. Why? Because no two brains, not even identical twins, no two brains will ever be the same, because a brain has a blueprint, which is the genetic code, something that mom and dad gives the baby when he's born. And then, as I mentioned, the experiences in the environment that shape the brain and how it develops, those two things will form the neuroarchitecture and will dictate whether this child will be, a musical prodigy, or whether this child is going to go on to be a CEO. So it's all in how you form these connections and what experiences and genetics are coming into play. And finally, this is the fun part. I would like to show you how I think about all these concepts. So basically, we now know a little bit about how the brain works. And these are, of course, this is just skimming the surface. But what I like to do, and this is my whole mission is actually to help children reach their fullest developmental potential. And another term for that is brain optimization. So my whole thinking is, how do we take these neuroscience tools, things that I will show you as an example in a minute, how do we take tools of neuroscience and apply them so that children will be able to learn better and maximize their time learning and optimizing their brain so that they can reach their fullest potential. So one of these, one of the first neuroscience tools I would like to tell you about is exercise. And if you recall, a few years ago, Michelle Obama took that on as an initiative called, she called it "Let's Get Moving," I think, the moving campaign. And she hit it spot on, because she wanted the children to get moving. And so now we know that exercises, we've always known that it's great for the brain. That's in fact how children develop, but taking it a step further, did you know that the chemicals released in the brain during exercise, let's say the hormones, for example, some of you may be familiar with endorphins, right? When we pump the blood throughout our body with the oxygen and nutrients flowing through all the tissues, the brain releases endorphins. So you might know that. And those are feel-good molecules. So if you think about it in terms of child development, the child is now ready to learn because these molecules make the child feel good, and it improves the mood for learning. So that's one thing. But did you also know there's another molecule that we call brain-derived neurotrophic factor? And it's a very special protein. And so this BDNF, we call it for short, is responsible for converting short-term memories into long-term. And so what it means for the child who just finished exercising and is now sitting down to learn is that the brain now is going to be much more optimized for the learning process. I call it prepped and primed to learn, because it's more motivated. The attention and focus, it's right there due to this important protein that has been released. And so just to give you something to think about, in some countries around the world, which I find absolutely fascinating, children begin their day with something they call the miracle mile. What it is they make the children run a mile around the school perimeter before the beginning of the school day. So if you think about it, what it does is by the time the child is ready, sitting down in the chair in the classroom and the teacher is beginning the math lesson, the brain is now prepped and primed for the learning process. So this is something that I would like to see integrated more in schools. Yes, we have exercise, children go to recess, but is it really heart pumping, running a mile, basically the exercise that will give you the most benefits? So that's the first idea I had to think about. But the second neuroscience tool to discuss is music. So I did mention a music example because I'm a fan of music and what it does for the brain, but it's more than that. Some schools, and I think it's fantastic, they have the children, let's say here in kindergarten, they begin in Wisconsin with voice lessons. They learn pitch, maybe different pitches and how to sing music. But if you think about it in terms of the science, which I've read very carefully, music performance, so taking an instrument as complex, it could be a piano, it could be a violin, and a lot of educators probably say, oh my God, a violin. Yes, I know, but if you read the literature and you introduce a violin, let's say, to such a young child, a kindergartner, yes, they might break it, but on the other side, the benefits to the brain are tremendous. I cannot even tell you, these papers, many papers, document over 20 brain structures that are constantly activated when you teach the left and the right hand to play music. And it's more than that, right? It's also performing music, because during performance, now you have an added element of cognition. There's so much more to it. Now you have to express your feelings when you play a song in front of an audience. There is so much going on. So I would like to see music as a neuroscience tool incorporated in a more rigorous way, because we know it really transforms the brain from the inside. Okay, so I hope that you found some of this information helpful. And I would love to hear from you some of your thoughts, maybe some questions, and then open the floor for discussion.
That was incredible. Thank you, Liraz. That was great. That's all very fascinating. I'm interested in what you were talking about with the different connections that are made with the hand and eye coordination, for instance, in music. Is there a sense that you said there's a lot of research already being done on that? Is that right? And if so, you said there's some countries, I believe, that's implementing that into schools. Is that looking to be something more widespread in the future?
I don't know particular research I know that research in music is going on everywhere all the time, and there are fascinating books about it that have been released. Some of them which I read. In terms of what it does for the brain is, let's say, and piano does the same thing. You have to coordinate left and right. So in terms of neuroscience, you could think about the corpus callosum, which is the part right here. And if you recall, this is half of the brain, but when you put the brain together, you have the right half, the left hemisphere. And when you put them together, the corpus callosum is the part that connects the two. And so you are actually, I like to say that music is literally a brain workout. You get so much more than just motor coordination, cross communication between the hemispheres. You get the expression through the emotions of music. You get planning and the executive functions in the prefrontal cortex. So there's so much going on. And I would say that I'm a little disappointed, because from what I know, and maybe every state is different, but in the state of Wisconsin, they don't start teaching the kids here and to play a musical instrument. I think it's until 4th grade, which in my opinion is super late in the game.
Yes, it is. Well, that's wonderful. Does anyone else have any questions or anything?
I just wanted to soundboard and say I, as an educator, really appreciate you bringing the research to qualify that both music and exercise work. I've seen that in the classroom. And then also as a mother, I'm invested in this too, because my daughter was born with agenesis of the corpus callosum. So I am looking to see, like, how do we how do we track that? I've done a lot of incorporating music and exercise in the classroom, but I wanted to see if there were any specific curriculums or things that you have found to be really excellent or kind of at the leading edge of that.
So you're asking as an educator, and I do appreciate the question. You're asking for if I've seen any curriculums incorporating these aspects into the classroom?
Yeah. Like I've
Okay.
done certain trainings and things, but I'm wondering if you have heard of anything that is really has been exceptional in terms of results for music or exercise in the classroom.
Yes, great question. You know, I don't have the answer to that because, as I mentioned, I'm a trained scientist. I have spent time in the classroom for my daughter who is in kindergarten, and I've seen her transition to Montessori. I'm a huge fan of that, but I haven't really seen a particular curriculum that I can name right now, but I've seen it work, you know, like the Montessori material, for example. If you think about a Montessori classroom for the very early ages, so, you know, they start Montessori, I believe, at the age of 1.5 to 2, her material, which is genius, and it's all, you know, it was constructed back in the day and it still holds today, is that they have those bells, right? And they learn I believe it's, I think it's I don't know if it's a 1 octave or a 2 octave scale, but they learn to play the bells by the end when they're done with the children's house, which is ages, I believe, 3 to 6.
Yes.
So I think that's excellent to incorporate it within the learning. And some schools here I know do, okay, now it's music time, now it's PE time. And I like to see it more integrated. Why can't we have science time with a little bit of music? Did you know violin ties to science? I can think of a million ways. So maybe kind of cross, what's the word? Maybe cross the paths a little more.
Like overarching curriculum, sort of? Would
Yes.
that be
Thank
considered integrated? Yes, that's what we aim to do. I think that's a great way to do it. Additionally, multi-age classrooms. Do you guys have any input on multi-age classrooms? I know that's a very Montessori thing.
Well, I'm also a newer Montessori guide. So this is my 2nd year teaching 6 through 9-year-olds. So I do see that multi-age level really supportive of this as well. So
That's very cool. Would you guys, could we go around the room briefly and introduce ourselves? Jamal, would you like to start?
Sure. Hi, everyone. Loraz, what a fantastic presentation. Thank you so much. I actually have a couple of questions too, but I'm Jamal Dapina, and I'm a technical consultant by trade, really appreciating what Amber's doing and what we're doing with Evolving in Education. And what a great presentation, kickoff for our first in a series of just tremendous brain power stimulation focus group presentations. I love it. Anything else? I don't know what else to say.
That's good. Ben, would you like to introduce yourself? Thank you for joining.
Hey guys, yeah, sorry, I was in the shop earlier rushing around. I didn't have my mic on, you might have heard me. That's me. Anyway,
No.
my name's Ben, I'm from New Zealand. I'm sort of more, I've been researching into my own brain, just trying to figure it out because for various reasons. And I'm sort of dived deep into the cognitive functions of my brain, the electrical activity of my brain, a few other good bits and pieces. So yeah, I just sort of, I'm a master's student, not in sort of anything specific to the brain, but I'm sort of, I'm building a sort of a project or a bit more of a project around sort of these areas really. So yeah, that's about me really.
Wonderful. Thank you. Thank you. Carol, would you like to introduce yourself?
Sure. I'm Kira. Hi. I am coming from Minnesota. This is Etta in the background. As I said before, I'm a Montessori teacher. I teach E1, so 6 through 9. I've been in education for, goodness, like 15 years, something like that. So I've taught toddlers through adults. Really excited about this team forming. And I'm also in a mystery school for brain research right now. So this was like, I saw this topic and I was like, yes, let's go. So thank you for the awesome information.
Incredible. Thank you. I'll introduce myself quickly. I'm Amber Smith. I started evolving in education about 8 months ago because I have 4-year-old twins and they're nearing school age and there's not a lot of options for good school here. So I learned about Montessori school, and I learned that there's about 500 public Montessori schools in the United States. And after I learned a Montessori, I learned a Forest school and Waldorf school. And so I thought, why not try to blend all these great holistic forms of education and make them available to everyone and inform them through brain science. So, and I have no background in education or neuroscience or anything like that. I actually do underwater construction and topside welding for a living. So it's sort of a strange fit. And I believe Ashley doesn't have her mic on. And Lemur, I believe you already, you're welcome to introduce yourself again if you like.
I think I've spoken, I spoke for 20 minutes. So, I just, yes, I'm a scientist. So that's really in a nutshell.
Yes. Jamal, you said you had a couple questions.
Yes, I found the information fascinating. I'd heard some of it before, but was wondering if in the research you had found a particular heart rate in the exercising, like the idea of going around the school a mile seemed like it would give them such a good workout. I'm wondering, is there like a certain amount that they want to attain that's optimal?
Yes. Well, first of all, let me just say thank you so much for your enthusiasm. To all of you, thank you for your comments about the presentation. Yes, Jamal, that's a great question. And I was wondering that myself. When we say exercise, I mean, is it yoga or is it heart pumping, cardiovascular mile, like we discussed? So in fact, there's an interesting study I came across, and that actually got my wheels or my brain spinning and thinking about this whole exercise topic. In this study, they took preteens, and that will address your question. They took 9 and 10-year-olds and they imaged their brain. Half of the 9 and 10-year-olds were sedentary. They sat around, they watched TV, they played their video games, and then their brains were scanned. The other group, they took those kids and they had them run for 20 minutes. And then, it wasn't run, it was brisk walking in the study. Brisk walk for 20 minutes. And then they set them down and put them in an MRI machine to image their brain. And what they found was fascinating. They saw changes in the volume of the hippocampus. If you recall, that was this structure on my half brain that controls our learning and memory. They saw an increase in the volume, which is amazing. That means there's some changing in the maybe the ability of the brain to process some of this information that will be the brain is more conducive to learning, I would say. And then the changes were so striking that in itself is a study to show you that exercise has huge benefits. So they claim now, yes. So I don't know in particular a heart rate target. I don't know a mileage per se. Should we put the kids on a treadmill or should we have them bike around the school? That right. I don't know. That's a more physiology. There's exercise physiology, which is a whole other field. But I would say that this should definitely prepare the brain for a lot of what it will be function at its peak efficiency if you exercise a child before you sit them down to focus on it.
Even brisk walking, though, that's amazing. And the other question I had, a little easier, was just when you're talking about using instruments, isn't the voice an instrument? And how in depth is the performance in voice compared to something like navigating the keys of a piano?
Yes, that's a good point. Voice lessons, that's very beneficial to the brain. Think about what you're doing there. Yeah, so your voice is your instrument, correct? And you have to match pitch as you learn how to sing. You're singing on the music. So if music is playing in the background, now you have to match the music. And now you're talking about, there's so much going on still. Yeah, I believe they do read notes, right? Those music, vocalists, they do read notes. So there's a lot going on there. But in terms of, let's say, as you compare that from a neuroscience perspective now, that has benefits on its own, right? But if you compare, if let's say your goal was to optimize, to get the most bang for your buck, so to speak, then I would definitely argue for a complex instrument like the piano, which merges left hand doing one thing, right hand doing another. That's how pianists play. And then you have to still read notes. You still have to match an orchestra maybe in the background. And so there's so much going on that I think it's a total workout for the brain, a much more intense workout.
That's interesting. So wouldn't that translate closely to like keyboard play and a remote control play with a video game?
Okay, I love that you say that because my husband plays tons of video games and we used to have
Right.
these discussions. Why are you playing video games? Why are you wasting your time? Well, you know what? One day I came across, I love to browse the brain section at the bookstore, and I came across multiple books about the benefits of video games to the brain. And it was fascinating. And I don't remember exactly how it works, but I do know that the manipulation of the controls on the video game with the left and the you have to do something maybe with your left thumb and maybe something with your right index finger. It's very complicated, and it's using, once again, fine motor skills, and you have to coordinate yourself visually inside a game, which is a pretend game, right? There's so much going on in that, and the learning curve on a video game that you also are doing a lot. You have a lot of benefits to the brain in that sense.
It's excellent to have that, like she was saying, verification through your research. And I love the concept of merging the fields and disciplines, what we're learning from the different disciplines, merging that together. Amber, that's our job right there, figuring it out and yeah, bottling it and regurgitating it nicely so that, folk can encapsulate it into their teaching. I love it. Good stuff. Thank you.
Yes. Quickly, Liraz, I would like to speak to you about mindfulness. Now, you said that they put children in MRIs, did MRI scans after they exercised, and it showed an improvement or increase in brain function. Now, I've heard the same with mindfulness practice. I've heard that MRI scans show that gyrification, cortical thickness, the cortical folding in your brain, is increased through mindfulness practice. That is very cool, in my opinion. And additionally, I heard that visualization, for one, is a form of mindfulness, and for two, visualization practice can be as good as actually doing the practice. Like, let's say I fly airplanes, so sometimes I used to, when practicing flying, I would go in my head, get in the airplane, go over my checklist, take off, fly around, switch tanks, land, etc. So I wonder if in fact visualization is mindfulness and how to best, I know that this isn't the focus group for mindfulness, but I would like to touch on that because it is proven through brain science, how to best incorporate mindfulness and visualization into the learning. I think that's something really neat to work on.
With meditation, so you get like the mindfulness, there's sort of 4 predominant types of meditation you can sort of do. So you get mindfulness, and they do different parts of your brain as well. So you can sort of do mindfulness, you can do sort of a concentration meditation, and you can do a sort of like a heart one where you're sort of just thinking love and stuff for everyone, and that does other stuff to the brain. And there's a 4th one I can't remember off the top of my head. So there's different ones, and I haven't heard about that visualization as being a part of meditation, but yeah, it's definitely, you're doing something cognitively with your brain, within it. So it's gonna, it's gonna have some impact, obviously.
That's fascinating. There's 4 types. I wasn't aware of that. And I'm not actually 100% sure that visualization is a form of meditation or mindfulness. It just seems to me like it is. Kira, do you have any idea if visualization is a form of mindfulness practice?
Yeah, actually, that's part of my study with this mystery school. It's called Praxis Aletheia, by the way. But so we're actually doing a brain first meditation. And there are 3 types of meditations where you can do like a broad, just like just like absorbing everything, but just kind of going within. And then a point of focus meditation is a very common one. And then this brain first meditation that we're learning is like a somatic. So it's initiating different points in the body and then bringing energy to the prefrontal cortex. So I'm excited about having this type of meditation that really activates the brain, because unless we're utilizing this latent energy in the body and the prefrontal cortex, mindfulness does have its limitations, because we will often go back into like the survival or reptilian brain. So
Yes. I think it's relevant to point out that meditation is mindfulness practice, but mindfulness practice does not only consist of meditation. For instance, gratitude journaling, nature walks, there's even mindful eating, which is pretty crazy. And children can close their eyes and be told a story. Thank you for sharing that link, Ben. I'll check that out. And the chat will exist for the meeting indefinitely. It's a chat that will stay. So I have a couple things, if it's all right with everyone, I'd like to touch on about just evolving in education's incorporating developmental neuroscience and psychology into our initiatives. So
Amber, before you get there, let me just say one sentence about meditation. It has been scientifically proven to work, meaning to calm the brain, calm the body. They call it, from a science perspective, calm the nervous system. And I'm super fascinated too with how all of this works. Just know that because I've seen this everywhere, they describe yoga, because yoga has a meditation, mindfulness quality, and also Qigong that's coming from China. These are ancient practices. One is from India, one is from China. These are ancient practices that have been ongoing for thousands of years. They absolutely work. It's proven that they work. And yes, they put monks in MRI machines. They've done some crazy studies, and they show that the monks, for example, are able to very quickly, in a matter of minutes, calm the brain and generate a brain activity similar to us sleeping. The brain has certain patterns, neurological patterns when we're sleeping. So yes, they're able to get into this deep calming state. I forgot the exact name of it, but
theta and delta.
Yeah, I was going to say theta, but I never say it without being 100% sure. Yes, so the theta waves, right? It's absolutely remarkable. We can get our kids there, I am sure. So it's not going to happen the first week or the first month. You could get kids there, but once again, you have to override a premature cortex. So that's something to think about, which it's impossible, right? This is premature. They still haven't built those connections yet.
Yes, I heard that Jose Silva, he invented the Silva method. I think he says that mindfulness is best for children to introduce it between the ages of 6 and 7. What were you going to say, Ben?
There's little tricks you can do to sort of get into those lower sort of brainwave frequencies, even as non-monks, you know, by doing breath work that can put your certain types of breath work, it will sort of stimulate those sort of lower frequency brainwaves. And also using the audio-visual entrainment, so using the sort of binaural beats or different names for it, but brainwave entrainment, where you use sound, or you can use light, different light, but I prefer to use the sound, and that will also stimulate those sort of brainwaves. And it's quite easy to do. So where these monks have spent 10, 30 decades learning their practice, by practicing with those with those audio brainwave entrainment techniques, you can actually sort of get to those states a lot quicker. So even in the classroom, you know, like Beethoven and things like this, that stimulates that sort of calmness. I think that Beethoven sort of stimulates, might be the beta or the alpha or the theta waves. And having sort of music like that in the classroom can, not necessarily that one, but can help with children as well, with this sort of just getting that brain into a sort of more calm and focused learning state. So alpha waves, I think, for the learning. So finding music that's got sort of, alpha in it. Basically, music can be used to help get the brain into a nice calm state as well. It's breathe breath work, you know.
Yes, that's wonderful. The potential of introducing mindfulness into schools just blows me away. There's a nonprofit organization currently working towards this called Mindful Schools. I reached out to them, but they said they appreciate what we're doing, but they're a small nonprofit, and at this point they can't get involved. But unless anyone has anything on what we were just speaking of on the mindfulness, I'll quickly go over a couple things on incorporating the neuroscience and psychology into our initiative. So this is more towards our teacher training objective, how neuroscience and psychology can inform our teacher training. And I'll go over this briefly. So research and gather relevant information. We can identify key principles, theories, and empirical findings that can inform teacher training through developmental neuroscience and psychology. Identify training needs, develop training materials, conduct training sessions for educators, provide ongoing support, evaluate the impact, adapt and refine the training approach. So continuously gather feedback from teachers and incorporate it into training approach, monitor the effectiveness of the training program and make necessary adjustments, foster collaboration and dissemination. I heard that one gap between neuroscience, psychology, and educators is the language barrier. So just breaking down those complex concepts, and Dr. Liraz, you do that very well. Breaking down.
Thank you. Appreciate that.
Making it understandable in lay terms. So foster collaboration and dissemination. By bridging the gap between developmental neuroscience and psychology and learning, we can empower teachers with evidence-based knowledge and strategies, leading to more effective and impactful classroom instruction. So here's a couple challenges to applying neuroscience and psychology to teacher training and education. So the implementation gap. While there is a growing body of research on how the brain learns and processes information, there is a gap between research findings and their implementation in educational settings. Translating complex scientific concepts into practical strategies that can be effectively incorporated into the curriculum and teaching practices can be challenging. But I don't fear, because we have Dr. Liraz for simple explanations. So another challenge can be professional development. Many educators do not receive adequate training or professional development opportunities related to these philosophies. Or understanding and applying research findings may require specialized knowledge and skills that are not commonly part of teacher training programs. Another challenge is lack of resources. The evaluation and assessment of these interventions may require assessment tools and methodologies that are not readily available or widely implemented. There's a barrier between collaboration and communication because, like I said, can be challenging due to varying priorities, terminology, and perspectives. So in summary, addressing these challenges requires fostering strong partnerships between researchers and educators, providing relevant professional development opportunities, promoting interdisciplinary collaboration, and developing practical frameworks for applying neuroscience and psychology into educational settings. And one last quick thing. So with our professional development programs, we can provide teachers with knowledge and strategies to better understand and support students' cognitive, social, and emotional development. We can also work on curriculum development, incorporating research-based teaching strategies, promoting experiential learning, and addressing the diverse needs of students at different developmental stages. Also, we can help with classroom environment, help educators create optimal classroom environments that support students' development. This can involve strategies such as organizing the physical space to encourage collaboration and exploration, integrating sensory experiences into the learning and environment, and promoting positive relationships and social interactions. So those are some ways we can hopefully incorporate developmental neuroscience and psychology, and also some challenges. Does anyone have any thoughts on any of that? I know I rambled through that quickly and it was sort of a lot. Apologize for that. If not, I guess we can, if anyone has anything else they would like to add or share, or any more questions.
I had a question for the neuroscience lady, so I didn't see your name. I can't see your name on just his iPhone for your, but you know, before you mentioned, you were talking about the prefrontal cortex. Is that like that whole part, that's those sort of parts of the brain, that's the lobe? Is the cortex like a smaller area within that frontal lobe? Or is the prefrontal cortex, what does it cover?
Okay, so if this is this is an adult-sized brain, the pink part in the front is the prefrontal cortex. Another name for it is neocortex. Neo meaning new. That is, in evolutionary terms, the new addition to the brain. This part is a different lobe. This is the temporal lobe, where the hearing occurs. So you know, you're talking about this pink part right here. And in children, we know that that much later. Yes.
Okay, so the whole thing is the prefrontal cortex. It's not just the frontal lobe, and the prefrontal cortex is within the lobe, the frontal lobe. Cool. And with things like, you mentioned the amygdala earlier, with the amygdala and the hippocampus, can you, if you're doing fMRIs on those areas, functional fMRI, can you see if those areas have got hyper or hypo use in certain areas and different regions within the sort of the brain stem and that sort of midbrain area? Sort of does that make sense? So can we see on an fMRI if there's hyper or over or under use of the amygdala or the hippocampus?
Oh, yes, certainly.
Does that make sense?
I don't know if fMRI would be the test to choose, but certainly, yes, in science, there are so many methods to image the brain and see the volume, for example, the volume, let's say hippocampus, the volume of the hippocampus, is it big or is it small in a child? Then you know, so for example, a person with dementia will have a smaller hippocampus because obviously the memory centers are starting to degrade because they have Alzheimer's, right? That's the easiest example to give you. But yes, there are so many different ways to image, so much technology and so many clever testing that scientists can do to discover. Not only that, you can look at the connectivity. As I mentioned, these are called synapses. So how many synapses are there? You can color code them in different colors. So it's fantastic what we could find out. Yes.
That is fantastic. I recently learned that the relationship.
And then in today's world, an exponential.
Sorry, go ahead, Ben. Say again, Ben. Sorry about that.
You're right. Go. Oh no, no, a minute. You go.
I heard that.
I'll carry on then. It might be a slight delay on the line.
Yeah, sorry about that. You come all the way from New Zealand. So
Yeah.
I'll go quickly. I'm sorry.
I'll go mute.
I heard that the relationship between the amygdala and the prefrontal cortex is directly related to mental health. I'm wondering, for one, are you familiar with this at all? That the connection between the prefrontal cortex and the amygdala is what determines your mental health. For two, I'm curious, are they working on trying to figure out a way how to improve the connection, to foster that connection, that relationship between the amygdala and prefrontal cortex?
That is a very complicated question, which, oh my gosh, I'm sure there are studies out there. In terms of mental health, yes, it's a huge issue, sure, for kids nowadays, right? We're talking in terms of your I'm assuming you're asking about depression, anxiety. Yes. What I can say, as I mentioned, the brain is cross-connected. A lot of structures communicate with the amygdala, which is the center of our emotions, not just and mood and all of that, not just the prefrontal cortex, but a lot of other areas. So it's very complicated. So in terms of stabilizing mood, let's say, for kids, there are natural, I would say, natural medicines. They like to start kids with maybe exercise, right? Exercise, because it releases a pharmacology, a whole pharmacology in the brain in terms of the neural factors that exercise releases, right? I talked about endorphins, but it does so much more to stabilize mood. So you might want to start there with with kids if you're thinking in terms of evolving in education. But are they studying it? Sure, a lot of people have been studying not only in humans, but also in rats and laboratory animals, because it's so much easier to dissect the brain and check out what goes on after a study and manipulation, a certain manipulation, behavioral testing. But I hope that answers the question.
Yes, thank you. Thank you, Limor. And
Was
Ben,
it-
I apologize again. Go ahead.
Well, just on that one, that's the thing with the different types of meditation available, like they call it metta meditation, which is in the Vipassana Buddhist technique. It's a love and kindness meditation. By doing that, you can stimulate, well, as I understand it, you can help stimulate the hippocampus, one of those. But with those different meditation techniques, you can actually strengthen those areas in your brain. Same as the concentration for the prefrontal cortex and things like that. So I think the tools are there, but I think neuroscience is just sort of catching up with to how we actually, really get to target it, which is sort of the area I'm working on. Because And another thing, I don't know if you guys have ever heard of heart coherence. So, you know, heart coherence. So your heart, we have a heartbeat, and you can measure the signals from your heart, right? And when you've got your heartbeat, it should be a nice sort of smooth and nice pattern, nice smooth rhythm. And if you measure people's hearts and their heart coherence is a bit out of whack, that can also impact the prefrontal cortex and the amygdala and that. Because I think I don't know if it's not necessarily the cause, but I think that the heart coherence being out of whack is another sign of the body's in a state of stress. And when the body's in a state of stress, we're having massive, like today's world, we're having an exponential rise of ADHD-like symptoms. I don't think they're all ADHD. I think a lot of it's the brain, because the brain is in a state of stress, that's causing a lot of these ADHD-like symptoms as well. I think along those lines, yeah. I'm not very good with my words, sorry. That's one of my weaknesses, actually, because I've done a bit of a deep dive. I did spend a couple of grand on a cognitive assessment. And one of the things I found out was that, it's the ability to be able to put the words together, which I think is your Broca's area. I don't know if you know Broca's area and the Winnick's area in the brain. I'm talking enough now.
I think you're very well spoken, Ben. You said that very well. Kira had a question. Could you say that again? The heart myopathy. What was it?
Heart coherence.
Sorry.
Heart coherence. Yeah. So doing that as well. I mean, it's just I sort of look at that more as an indicator. It's an indicator of something isn't right, And I do believe that. And if we were to, maybe you'd know, Doctor, like in the neuroscience, are we seeing the structural and operating changes in the brain within our younger people today, because you're growing up in a world like the stress that the whole world has put under in the last few years? That's going to have a massive impact on the youth and their developing brains. So I think we're going to see an explosion of ADHD-like symptoms. I don't think they're necessarily going to be ADHD, because it's the way the structures in the brain are working. And the reason I know this is because this is how I dove deep into my brain. I had a brain map done, so a QEEG brain map. So it's sort of like an EEG, but they quantify the data, so they can sort of see where that information is coming from in your brain. They don't use it for diagnostics, but you can use it for insights into the brain. And having that done opened up so many different aspects of how my brain was working. And when you can put that in conjunction with the cognitive assessments as well, you can sort of really get an overall picture. Anyway, that's about it.
That's fascinating, though. You had your brain mapped. I wasn't sure you could do that. I told someone the other day, I said, I'd like to go into a doctor and then hook me up to a machine and have them tell me exactly where I'm deficient, exactly where, I'm overactive. I heard someone talk about one day they'll have a blood test you can take, and they prescribe you neurotropics based on your DNA and blood test for that day, which is
it's all coming. It's all coming.
Yep.
Yeah.
Changes are coming. I look forward to helping foster the future of education with Evolving in Education, and I'm sure glad to have all y'all on board. We will have another focus group meeting next week. It will be our mindfulness, fitness, well-being focus group meeting, and we have a general meeting tomorrow. I welcome you all to join. It's at 3 p.m. Central Standard Time. But I can't thank you all enough for joining today. And would anyone else like to add anything before we wrap up?
I have one more question, if I may.
Yes, go ahead.
Is, you earlier were talking about the development of the executive function in the brain, the development, when does that sort of, what developmental stages are there? Like when does it sort of become, is it like when we're 25 as adults that sort of prefrontal cortex is fully developed? Or when does it sort of become fully used in the sort of, in an age group,
Yes, so in terms of development, okay, it starts from actually some scientists claim it does start inside the womb. Yes, during the production of the embryo. I mean, everything starts from the moment the spinal cord and the brain are formed in utero, and because this fetus can still hear its mother, it can still respond to temperature changes in the environment. So there's definitely something going on starting before birth. So it's crazy to think about, all the way up to, as I mentioned, mid to late 20s, depending on the person, because no brain is exactly the same. And so I was just mentioning that as the potential. Yes, and in terms of prefrontal cortex, yes, we know that that's the less structure that really fully develops in kids. That's why they may have problems with inhibition control, controlling, touching a certain candy when they're not supposed to, that type of thing. But I was mentioning it as a springboard for evolving in education, because that means you have 0 to 20, let's say 5 or even 7 to impact this brain. That's incredible.
Awesome. Yeah, cool. Thank you.
Yes.
Wonderful. Thank you guys all so much. And like I said, the chat will exist indefinitely, and there's some good links in there. I invite you all to check those out. And again, I can't thank you guys enough for joining today. I look forward to seeing you at another meeting, and just thanks again.
Awesome. Thanks, everybody.
Cool. You guys have a
Bye.
wonderful rest of your week.
Have a good night.
everyone.
Thanks. Bye.
Thanks, y'all.
Ciao.
Hey, Ben,
That's right.
could
Yo.
I ask quickly? You're not the guy that does the excuse me. You're not in